Have you ever wondered what lies beneath your feet, or below the endless expanse of the ocean, and how it shapes the world as we know it? Today, we are taking a thrilling dive beneath Earth's surface to answer a deceptively simple question. How many tectonic plates are there? Curious? Smash that like button, subscribe for weekly Earth science deep dives, and let's set our planet in motion. When you look around, Earth seems solid, unmoving, permanent. But that's an illusion. Beneath your feet, massive slabs of rock are constantly shifting, colliding, stretching, and grinding past one another. This hidden motion shapes everything. Why volcanoes erupt in some places but not others? Why continents were once joined and will drift again? Why the Himalayas are still growing and the Atlantic is still widening? The reason behind it all? A powerful theory called plate tectonics, one of the greatest scientific breakthroughs of the 20th century and the key to understanding how our planet works. So what exactly is plate tectonics? According to the plate tectonics model, Earth's uppermost mantle plus the crust above behave as a single, strong, outer shell. This is called the lithosphere. But here's the kicker, the lithosphere isn't one solid piece. It's fractured like a giant cracked eggshell into segments known as plates. Below the lithosphere you'll find the Asthenosphere, a weak, ductile region of the upper mantle about 100 to 200 kilometers deep, where high temperatures and pressures push rocks close to melting. Here, rocks flow, letting the rigid plates above move independently. This is why Earth's shell can shift, slip, and even break apart, because it's essentially detached from the churning layers below. Tectonic plates aren't all the same, they carry two types of crust. Oceanic crust is thinner, just 7 to 10 km, denser, and mostly made of basalt. While continental crust is much thicker, about 25 to 80 km, lighter, and mostly granitic. Most plates contain both. That's why land masses and ocean floors move together. So, when we ask, how many tectonic plates are there, the global stage is dominated by 7 major plates and together, they cover about 94% of Earth's surface. Each includes both continent and ocean crust. Let's set off on a whirlwind adventure around the globe, following the grand sweep of Earth's 7 major tectonic plates, each with its own character, drama, and role in shaping our planet. We'll begin our journey somewhere in the endless blue of the Pacific, where the Pacific Plate reigns supreme. This colossal slab covers nearly a fifth of Earth's surface. Imagine a plate so vast it swallows almost the entire Pacific Ocean. As we travel its edge, we trace the infamous Ring of Fire, a rim of booming volcanoes and trembling earthquakes, all fueled by the restless energy beneath. And make no mistake, the Pacific Plate is the speedster of the tectonic world, cruising along at nearly 10 centimeters a year. Hop eastward and you land on the robust North American Plate. This isn't just the foundation of the US and Canada, it stretches beneath the Atlantic, includes Greenland, and even reaches into far-off Siberia. It's home to the iconic Rocky and Appalachian Mountains, and if you listen close enough, you might even hear the subtle grinding of the San Andreas Fault, one of Earth's most famous geologic hotspots. Slide south and you'll find yourself riding atop the South American Plate. Its western edge is a zone of raw energy, where the Andes Mountains punch skyward, fueled by invisible but mighty tectonic forces. With half of the South Atlantic floor and lush, sprawling rainforests under its footprint, this plate is rich in both life and seismic spectacle. Now, sweep eastward across the Atlantic to touch down on the African Plate. This dynamic slab hugs not just Africa, but also stretches into the Mediterranean and Atlantic. The East African Rift is literally pulling the continent apart, hinting at a dramatic future where Africa could split in two. Legendary volcanoes like Kilimanjaro bubble and fume atop this plate, telling stories of constant change. Next up, the Eurasian Plate, a true titan that spans Europe and most of Asia. Think vast plains, restless Mediterranean basins, and the ultimate showdown, the mighty Himalayas. Here, the Eurasian and Indian plates collide every moment, building and lifting the tallest peaks on Earth, a jaw-dropping display of tectonic strength. Glide southeast and you'll arrive at the Australian Indian Plate. Once thought to be rivals, these two now move mostly as one, carrying not just continents but immense stretches of ocean floor. This plate's northward push is responsible for the Himalayan clash, and its journey continues to rumble deep beneath Asia. Finally, we journey all the way south to the icy expanse of the Antarctic plate. This frozen behemoth is slow but mighty, gently drifting and creating new ocean floor as it goes. While mostly hidden beneath ice and sea, the Antarctic plate quietly influences global ocean currents, and by extension, the planet's climate. Each plate's story includes drifting continents, beautiful mountain ranges, deep-sea trenches, and sometimes, catastrophic geological events. But our world isn't just made up of these 7 giants. Stay tuned as we zoom in even further to the world of intermediate and microplates, where the action gets even more intricate. Besides the 7 giants, several minor tectonic plates play crucial roles in shaping local geography and hazards. Let's meet some of Earth's less famous, but totally fascinating, tectonic players. Imagine the Somali Plate making a slow-motion escape from Africa, opening up the massive Great Rift Valley and maybe, just maybe, giving rise to a brand new ocean in the distant future. Just to the northeast, the Arabian Plate is flexing its muscles, pushing up the jagged Zagros Mountains and prying open the Red Sea. Heading westward, the Anatolian Plate beneath Turkey stirs up frequent and sometimes fierce earthquakes as it slowly slides away, while to the northeast, the Amurian Plate keeps things lively in eastern Russia and northeast China, with its share of seismic activity. Okhotsk Plate sits further east, spanning parts of Japan and the Kuril Islands, a true hotbed of seismic and volcanic action. Moving south into Southeast Asia, the Burma or Myanmar Plate is a major factor behind local tectonics and seismic risks, and right next to it, the Sunda Plate is the force behind Indonesia's spectacularly explosive volcanoes. Eastward, the Philippine Sea Plate shakes things up with eruptions and earthquakes across the Philippines and nearby Pacific regions. Now, heading east across the Pacific, we reach the Americas. Off the west coast of South America, the Nazca Plate is always diving beneath the continent, building the ants and triggering powerful quakes. To the south, the Scotia Plate is squeezed between South America and Antarctica, spawning rare undersea volcanoes and unique island chains. Traveling north along the Pacific margin, the Cocos Plate keeps Central America on its toes with seismic action, while in the Pacific Northwest, the pine-sized Juan de Fuca Plate powers the Cascade volcanoes. Finally, the Caribbean Plate rounds out our journey, supporting a region of dramatic volcanic islands and earthquake hazards. There are around a dozen or more recognized intermediate plates globally, but their exact number varies, as plate boundaries can merge, split, or shift over geologic time, continually reshaping Earth's tectonic map. Each of these minor plates shapes earthquakes, volcano chains, or even entire regions, often in dramatic and unpredictable ways. As we zoom in even more, we meet the microplates, miniature plates often less than 1 million square kilometers. Microplates form at mid-ocean ridges, triple junctions, or transform faults. They're dynamic, breaking off from larger plates, merging, or vanishing over millions of years. Two fascinating examples include the Easter microplate, a rapidly rotating sliver of oceanic crust near Easter Island, squeezed between the Pacific and Nazca plates and notable for its active deformation and spreading. And the Galapagos microplate in the eastern Pacific, located at a triple junction and famous for its connection to both seafloor spreading and the discovery of deep-sea hydrothermal vents. Microplates highlight how Earth's surface remains a living mosaic, with new pieces continually forming and reshaping at the edges of major tectonic plates. One of the main tenets of the plate tectonics theory is that plates move as semi-coherent units relative to all other plates. As plates move, the distance between two locations on different plates, such as New York City and London, gradually changes, whereas the distance between sites on the same plate, Paris and Madrid, for example, remains relatively constant. Because plates are in constant motion relative to each other, most major interactions among them, and, therefore, most deformation, occur along their boundaries. Plate boundaries. These are the lines, often mapped by clusters of earthquakes or volcanoes, where plates meet and the surface is born, recycled, or shattered. Plates are bounded by three distinct types of boundaries, which are differentiated by the type of movement they exhibit. First up, divergent boundaries. This is where plates pull apart from each other, making room for magma to rise up and create brand new crust. If you want a mental picture, imagine the Mid-Atlantic Ridge, an underwater mountain chain that's basically the world's most epic conveyor belt, cranking out fresh seafloor as the plates separate. Next, we have convergent boundaries. Here, plates are on a collision course. One plate usually dives beneath the other, sometimes ocean meets continent, or continent meets continent, leading to deep ocean trenches, dramatic volcanic arcs, and even the rise of immense mountains like the Andes and Himalayas. Finally, there's the transform boundary. Instead of pulling apart or crashing together, these plates simply grind past each other side by side. The most famous example? California's San Andreas Fault. This sideways shuffle doesn't make new crust or destroy old crust, but it's great at generating earthquakes. Divergent and convergent boundaries each make up about 40% of all boundaries, while transform faults account for the remaining 20%. And remember, over geologic time, plates can merge, rip apart, migrate, or even vanish. Earth's tectonic story is always being rewritten. So, how many tectonic plates are there? 7 major plates form the core of the puzzle, many intermediate or minor plates and numerous microplates, less than 1 million square kilometers. If you count them all, Earth has roughly 2 dozen major, minor, and microplates, though the numbers shift as science uncovers more. No matter the exact count, what really counts is this: Earth is alive, ever-shifting, and full of surprises beneath our feet. Now you know the basics of Earth's moving puzzle. Which plate do you live on? Let me know in the comments below. If you enjoyed this journey, don't forget to like, subscribe, and check out my playlist for more Earth science deep dives. Remember, it's a moving story, so stay curious.